Thanks to the organizers of the Civil Engineering Week for inviting me. Welcome professors and students from this School of Civil Engineers in Valencia. Today I'm going to give you a quick talk, because we are already running late, about ancient engineering. I am going to talk mainly about engineering prior to the Roman world, much earlier, sometimes millennia before the Roman world, so that you can see that almost none of the achievements, of the enormous achievements that are being made today, are new, and that ever since civilization emerged, there have been enormous engineering works, unthinkable for most technicians and even the common people of our days. For example, this type of lifting wheels, which almost everyone knows, which already in the 4th millennium are found with certain varieties. They were used in the Mesopotamia area. You know that civilizations began in what is called the Fertile Crescent, which in short are the valleys of the Nile, the Tigris and the Euphrates. Recently, there is an area that leaves that crescent. It is the Indus Valley that has been studied especially in the 20th century, the Mohenjo-Daro and Harappa area that we will talk about later. They were probably the most advanced at that time in the 4th millennium before Christ, as in 3000 and many before Christ. Irrigation systems were very advanced. They had navigable canals, inland ports that communicated with the sea through canals, through the respective delta, and of course the water had to be raised on many occasions. Firstly, I'm going to talk to you about a series of devices and essential techniques for the development of engineering achievements that you are going to see later and that you would not understand if I did not explain to you that they had these characteristics. This is the Archimedes screw, which everyone has heard of and which works approximately in this way. You see that by turning, the water rises. The invention is attributed to Archimedes and it was probably invented by him, but I say probably because many other things later have been found out that already existed in earlier times. You will see some of the things that I showed you, not only devices, but also techniques, which existed long before those who claimed to have invented them. Another system of water lifting was the Noria of Rosario. This one had the advantage that it could lift the water more than 40 meters. What really raises the water is not a pump, nor a propulsion. It is a system of balls with a leather disc and chains that join them, turning a water wheel with whatever system it was, raising the water to about 40 or 50 meters. The remains have been found in several places, such as the Antikythera shipwreck, which dates back to 200 and a little after before Christ. In the Roman mines of Ardituri, there are several places where this type of artifact has been found, in this case water lifting mechanisms. This is a genuine pump, a propelled double-acting piston pump, the Ctesibius pump that you may have also heard of. A pump which there are remains in several archaeological museums, in Madrid, for example, in London, etc. Pumps that have been used in the Roman world and in Alexandria. The first evidence that we have are from the 4th century before Christ, when they were used in Alexandria. By its very nature, it allowed water to be raised far beyond atmospheric pressure, that is, far beyond 10 meters, probably up to 20 meters. This was used by the firefighters to put out fires in Alexandria and of course throughout the Roman world, throughout the Mediterranean. Inventions that were forerunners, for example, of pneumatics, such as this fountain by Heron of Alexandria, which through the pressure of the water exerted on the lower vessels in the air, in that empty conduit that you see, achieved a kind of permanent movement of the water, as well as ornamental or other types of fountains that could be installed at that time. Here you have a video of a few seconds, very short, where you can see how they work. As with a container above and 2 containers below, which are connected at the bottom, they are capable of generating this continuous liquid movement. Heron of Alexandria is from the 1st century after Christ. Based on the same system, on the same principle, there are these mechanisms or devices that allowed, thanks to the heating of the air with fire, as long as the fire was permanently burning, the doors remained open. A pneumatic system of hot air that closed and opened the doors of the temple. While the fire remained lit, the doors remained open, and that amazed the contemporaries. They had machinery of all kinds, for example, this that appeared in Hierapolis of Pamukkale, in the Hellenistic world of present-day Turkey, is a stone sawing machine. In addition to being explained there in Greek, they have been reconstructed, and it has been possible to know how this hydraulic machine worked, by means of a hydraulic wheel, which was a factory for sawing ashlars and stones of all kinds. You see, for example, the remains of a sawmill of this type in Gerasa, a city in the east, in present-day Syria. These others from Ephesus, one of the spots where a stone-cutting factory has been found, which was installed here. This has been well studied and is known to be like this. There goes the water that moved the hydraulic network, etc. For those who don't know, in the Pyramid of Cheops, in the interior ashlars, those that are not outside and not exposed to the weather, there are remains of those sawn ashlars. It's complicated. We're talking about the Bronze Age, in the Pyramid of Cheops, that is, what material did they use to saw that? It wasn't an iron saw, but it was probably strings with silica sand or whatever, but they already saw the ashlars in an industrial way at the time. Thales of Miletus, another of the characters of the 6th century before Christ, surely essential for trigonometric calculations nowadays. I repeat, 6th century before Christ. You all know the Thales' theorem. Since it is there, I don't need to explain it. You see that it can have a certain complexity. This man also extracted knowledge from Egypt. He was Greek logically. He took knowledge that had a certain practical application at the time, both for measurements of inaccessible points, as it could also be in matters of war. Be aware of the fact that in war machines it was essential to have a calculation to know the distance they could reach and the height. Quick calculations of this type, by similarities of triangles, allowed them to know if they were in the exact position. You can't think twice about that, because they shake you from the wall as long as you're not on the spot and shake yourself. In other words, it had several applications. This is the Pythagorean theorem. Everyone knows Pythagoras. It has always been thought that it was Pythagoras who invented it and who developed it, but this is not true. Here you have a Babylonian tablet from the 18th century before Christ that perfectly explains and develops the theorem that was later called Pythagorean. It is called Pythagoras because it has reached us through Pythagoras, but the Babylonians worked on this much earlier, and probably the Egyptians and probably others, because the works that can be seen in Egypt, many of them are impossible without having this type of technical knowledge. I mean, they didn't invent this. The problem is how it has come to us and what we have interpreted about who had invented it or who had developed it. Here you have the explanation of this tablet, with cuneiform writing, which perfectly explains what we know as the Pythagorean theorem. Moreover, this other tablet called the Plintum tablet also appeared, from the same period, from the 18th century before Christ, with tables for quick resolution of right triangles, so that, if they had the need at that time to solve triangles, which can happen precisely to use certain topographical instruments that require rapid resolution, like we have had other complex tables of logarithms, etc., they had their tablet, so it worked more or less like this. In other words, given two sides being the right triangle, they had already solved the other unknowns quickly. Of course, by the Pythagorean theorem you have to solve it, but they were already solved in a table. Take this, for example. This talk is very nice, also, for you who are current engineers or in the making. These are the conic curves, as they are called, which are formed by the intersection of a plane with a cone. Depending on the angle with which it intersects are different. Well, this was invented by Apollonius of Perga, the great geometer of the 3rd century before Christ. Perga is a city in Lycia, in present-day Turkey. This man, in addition to these curves, who developed them, described them graphically, since numerically there is no evidence. Among other things he developed the famous problems of Apollonius, which I don't know if they are studied today. I am an antediluvian, are they still studied nowadays? Well, you know that there are 9 cases that really consist of the calculation of a circumference that is tangent to 3 others. Other 3 that can have all the variations of size, from 0 radius, which is a point, to infinite radius, which is a line. There are 9 cases, plus a 10th that cannot be solved graphically, that is, with a set square, triangle and compass. It requires numerical calculation, and it was Newton, the famous Isaac Newton, who finally solved it in the 18th century. But the other 9 are from Apollonius of Perga from the 3rd century before Christ. It is very important that I emphasize to you where these techniques come from. Let us not think that we are inventing things and that modern universities are the only ones that do these things. Essential tools to do the works. This was called the chorobates, described exclusively by Vitruvius, who was an architect, not an engineer. He describes it in his treatise. It has been interpreted in many ways. These are some of the erroneous ways of interpretation, in which they thought that the ends had legs, which they thought was a table. This is absolutely useless for any leveling. If it is translated correctly from Latin, as you are seeing here, those ends were not legs, they are transverse arms or corbels, and, indeed, there were already ancients who interpreted it that way, especially from the 16th century, for example, Leonardo da Vinci. Even in one of the manuscripts of the Treatise on Engineering and Machinery, by Juan de Lastenosa, one of the Spanish sages of the 16th century, it is drawn very similar to how it was, because they probably knew more Latin than these others that I have just showed you, that they are already from the 17th and 18th century, where the interpretation was distorted and it has remained. Well, correctly interpreting what is said in Latin and passed into Spanish correctly. In this evidently a Latinist had to help me at that time because I did not control Latin for these things. This is what Vitruvius is describing to us of what it was, the chorobate. This is the leveling machine that I rebuilt many years ago, like in 2004, and put it to use many, many times. I have exhibited it in many cities, in things like these, like in Tarragona, in Tarraco Viva, etc. You see how the operation is simply to match those 3 lines of the chorobates, which is about 6 meters long, 20 feet according to Vitruvius. With a tablet that is placed at the bottom, no further than 30 meters or 50 meters, because in addition to the lack of recognition of the human eye, which is important, you know, and if you do not know it, you should know it, that the error of the sphericity of the earth is very important from 50 meters and leveling cannot be done well. Those who level the ditches, the farmers, know it, for whatever reason. If not, the ditches won't work out for them. Here you see how the center line, the top line, or the bottom line match together. This matches perfectly with the optical level. We have made it coincide and we have leveled lengths by iteration, repeating them, and the same precision is obtained as with an optical level, which also has its errors, with which you also have to do the iterative leveling. Remember this topography stuff. More things, they knew much more, of course. Vitruvius himself says this phrase of which I only highlight what is in red. He claims that Archimedes believes that water does not have a horizontal surface, but is spherical in shape and has its center at the center of the earth. This is the key to a good leveling. If we make a leveling greater than 50 meters long, we make very important mistakes. The ancients knew this perfectly. Look at what Vitruvius says, and he didn't even invent it. He is quoting Archimedes' works, which I have already told you is from the 3rd century before Christ. This is the famous sphericity error of the earth. Look at the formula that you see there, the modern formula, the one that we use, but over 50 meters the errors for the water channels and the minimum slopes that are handled begin to be very important. I have been told cases of people who, using an optical level, which has significant optical acuity, because it has lenses, have tried to level almost a kilometer, because you can see the scope in the background. The water not only doesn't flow there, but it can also come towards you, and this is a disaster. The issue of the sphericity of the earth must be considered in every leveling. Here we see this manuscript. I have other examples, but we have no time to show all of them, from the book that I have told you about engineering and machinery. You see how they interpret the chorobates. This type of instrument was even used in the 16th century, which I discovered back then. In the end, when you handle manuscripts, you just realize that others had already done it before. Another topographical instrument that is described by Heron of Alexandria is the dioptra. Heron had a treatise on the dioptra. That treatise must have had about 15 pages and 2 have been preserved. They are not even contiguous. Look at the difficulty in knowing how the heck that was, but with the few things he says, one already realizes that it looked like this. It had a horizontal plate, a semicircle also graduated vertically, etc. A theodolite is actually being described. This instrument has had many interpretations throughout history, all absurd, because unfortunately almost all the professionals who are dedicated to interpreting these instruments are people from the humanities, and you will understand that they do not know much about this. So more or less they paint what they understand to be there, and they painted instruments that were also useless, of course, that were useless to perform the function. However, both with the description of Heron and Polybius, and it is well known that Hipparchus of Nicaea of the 2nd century before Christ, a Greek and an excellent astronomer, also handled the dioptra, in this case to make astronomical calculations. I'll tell you quickly. Hipparchus is one of the people who adopted the geocentric theory, against Aristarchus of Samos who had postulated the heliocentric theory. Until the 17th century with Copernicus this does not happen again. The theory of Aristarchus of Samos was not successful. You know what the heliocentric theory is. They even accused him of being impious. That is, for the philosophers and the religions of the time it was not accepted that the earth was not the center of the universe. However, Hipparchus managed to set up a universal and planetary system in which, with the earth in the center and a sphere, let's say celestial, with its measurements, it worked perfectly for him. In fact, it worked until Copernicus period without any problem. Copernicus had difficulties in demonstrating his own, because the other was working, although he started from a false axiom. Hipparchus perfectly calculated the diameter of the sun, the diameter of the earth, the distance between them, the diameter of the moon. All this has been known since the 3rd century before Christ. Forget these myths that say that people thought the earth was flat until Columbus. That is not true. No one has ever thought that the earth was flat. The sages of antiquity, all of them, including Strabo in his writings, speak of the spherical earth, including the diameter that Eratosthenes of Cyrene calculated with absolute precision. You know that he made a measurement with a gnome, with a stick, with a shadow, with a simple trigonometric formula that I don't have time to explain, but they already had it very well calculated. There have never been more flat earthers in history than today, because we are many. There was never, neither in antiquity nor in the Middle Ages, flat earthers. In fact, Columbus had no difficulty in saying that he wanted to go to the Indies. Everyone knew that by going west one would reach the Indies. What happens is that the wise men of the time, advisors to the kings of France, Portugal, and Spain, whom Colin tried to convince, they knew that the diameter of the earth was enormous, much greater than what Columbus believed, and they were absolutely right. If the earth was flat, he would never have arrived to the Indies, but he was lucky that a continent was found in the middle, with which everyone marveled. They said, "So, our calculations were wrong? The ancient ones were wrong?" No, they were good. The one who did not have good calculations was Columbus, who was suicidal, but he arrived. I have deviated because, effectively, these theodolites, after all, were the ones that were used for these ancient calculations, and finally this is a theodolite. Do not think about it anymore, this is what the dioptra was. With this, it is possible to do, not only everything that I have told you, of course terrestrial measurements. How are you going to do, for example, a division like the ones they used to do, centuriations with 60 kilometers on each side, like the ones in Italy, perfectly square? This cannot be performed with any alignment instrument. First you have to do geodesy, you have to make a precision map and rely on the vertexes to adjust those grids, but in these subdivisions of which traces are still preserved in the orthophotos, a transparency is placed and they are perfect, and it has only been possible to do it through geodesy. And what about the hundreds of kilometers long aqueducts that were built, in which the sources were very far away, and it was necessary to find out, not only the route of the canal, but the total level between the sources and the destination? Without a good map that is not done. Of course, they did it, because there was no other choice. No one can do such a work without an instrument and an acceptable map. Now you will understand why the realizations that I'm going to tell you about were made in ancient times. Here you see the practical application of a quadrant, which was called this, which is a Renaissance diopter, very rudimentary, much more rudimentary than Heron's, which was already lost. Like with a quick calculation about the distance to the target, if there is gunpowder then for a cannon, and, if not, for a crossbow, and, if not, for a scorpio like the Romans had with spears that were launched from a machine, a giant crossbow. Each machinist or each artificer knew where his spear reached, he had to put himself in the exact place for the attack to be effective. Topography was done, the first thing that came into any battle was the topography, to know where they had to be placed, and the technicians were the first ones, even if it was only for war purposes, this was essential, and it is perfectly unknown. You can see here how by relying on two segments on the ground, the flat area, can be made by solving triangles that, of course, they knew how to solve triangles perfectly. We have already gone much further back, they could perfectly make their maps that we do not know how they were represented, if with contour lines or with what kind of drawing, because nothing has come down to us. Neither maps, nor engineering treatises, nor texts of any value have reached us. I insist, the one by Vitruvius, which is the only one that has come down to us, is by an architect. It does not talk about engineering, absolutely nothing. They had very complex machines. This appeared in the shipwreck of Antikythera, 200 BC, which I have already told you about. It is the Antikythera mechanism. There are tremendous interpretations, because there are perhaps no adequate technicians to take care of these curiosities. You see that it has gears and several interlocking discs. This is what more or less has been interpreted of how this was, how it was made. A tremendous complexity. This is a video capture that they put in the Museum of Athens. I have seen all these mechanisms in person, the photos are mine. Well, after giving it a lot of thought, they have deduced that this was to predict eclipses. Just think, for any civilization, how many useful things could be done with this calculator, for example, to quickly solve trigonometric questions for what I have told you, for war, for civil works, for public works. And what a useless thing it is to predict eclipses. A civilization can live perfectly well without predicting an eclipse. As if there are no eclipses. But since the people who interpret these things are other kinds of professionals, everybody says that this is to predict eclipses and everybody is very happy, everybody has accepted. The whole planet. That this is to predict eclipses. It turns out that nothing more than this bronze pastiche is known, it can be anything, and the logical thing is that it has a useful function, because if not nobody starts to manufacture this is the issue. Let's go back to the 4th millennium BC, in Spain, Los Miares, the Chalcolithic, the Copper Age, Almeria. These are the first important settlements that can be called cities. No city in any period of history can survive without water. It can be an agglomeration of people, whatever you want, but to be a city and be in conditions and have security, you need water. There you see a canal, which has been very well documented by archaeology, that enters up to a kind of raft that feeds the bottom, but that crossed the entire city. That is lower than this. It comes from very close sources, 2 or 3 kilometers, which can be seen on topographic maps at a scale of 1/25,000. These springs fed the canal. A city with a water supply from the 4th millennium BC, from the Chalcolithic period. I like to highlight the dates, because I have to explain that since there are cities there is water supply, there cannot be any city without water supply. We are going to go now to the Indus civilization of which I have already spoken, The Indus Valley where this civilization developed is the current Pakistan approximately, very unknown because it is in the 20th century when this has been discovered and work has begun, with which, in the oldest texts it is not there. In fact, in geography and history, in Spain, this is practically not studied. It is mentioned that it exists, but it is not attacked in depth, like Egypt and Mesopotamia. They had inland shipyard ports, as you see, navigable canals, and an already quite decent urban structure, as you see here. This is the rest of the shipyard port that I just showed you. You see several pictures. They had some wells too, from where they got water, but the water usually came from outside. They had sewage, they had a perfect sanitation system. Here you see all kinds of channels, probably rainwater, some of them, also fecal, because this is a latrine that carried water underneath and there, they did their needs that dragged the water. This is from Harappa, one of the cities, and it is dated to the 3rd millennium BC. Well, they had latrines, running water and sewage, so how are you going to have sewage if you don't have running water? What happens under the toilet when you are there? Water supply. These are other latrines also from Harappa. This is one of the sewers, let's call it that, also from Harappa in the Indus Valley. Mohenjo-Daro, a general view of the city at that time. You see how in Mohenjo-Daro, in the upper area, there is a pool that archaeology has thought that its function is ritual. Well, I do not know if it was ritual or not ritual, but how the water is carried there. What worries me since I knew it is how the water is carried there, to the upper part of the city. How do they fill it? Not with rain, there is desert precipitation there. They had an external water supply, of course. 3rd millennium BC. This is a general view of Mohenjo-Daro, with the pool in the area that we have seen higher up, then it has more city towards the hillside downstream. They had supply, of course they did. This is an interpretation of the archaeological drawings that tell us that they filled this. I don't care if they did rituals, if they bathed, or if they drank it, or if this was covered as a kind of flow regulator or even a decanter. We don't know, because it has not been studied. I have not been to Mohenjo-Daro, but the water had to be taken there. More sewers of Mohenjo-Daro. Interior of the sewers. As you can see, there was no vault, there was no semicircular arch, it is a vault by approximation of rows, are the old closures of the false vaults that are called sewers, city drains, etc. Old drains, another latrine also of Mohenjo-Daro, no longer of Harappa but of Mohenjo-Daro, both cities had them. This is a gentleman showing what that was for, a gentleman from there, from Pakistan. I mean, the two big cities had latrines. That's one thing is a very advanced sanitary engineering, with latrines with running water. In Spain there haven't been many until the 20th century, and in some countries there still aren't. Watch out for ancient civilizations. This is a general map of what that civilization was in Mesopotamia. The different cultures that there have been, you have the legend there, Sumer in the 3rd millennium, the Akkadian Empire, also the 3rd millennium, the Babylonian, in the 2nd millennium and finally the Assyrian, who conquered even Egypt, in the 1st millennium. All of them had real wonders, probably the Assyrian even had a road network, because a network of markets and trade is mentioned in their cuneiform tablets, but it is not said how they communicated, although they had to have it. This is a map of the city of Ur, which is the one you see here, almost coastal at that time, not today. Today it is far inland, because the sedimentation of the delta of the Tigris and Euphrates has advanced in the Persian Gulf in a tremendous way. It also had its canals that communicated with the sea. It was coastal, but not so much. They had to go to the sea and from there they entered these inland ports. They sailed and traded with each other. Objects from the Indus have been found in Mesopotamia and that would mean a coastal navigation around the Arabian Peninsula. Look at this city, it already has an important aspect of a city. Of course it also had to have water from the outside. It cannot live without water and if they drink from the river they die. No one better than you know it. The water of the rivers is never drinkable. Nor did they have great purification systems. This is Babylon. Babylon came to have an impressive splendor and size. They also had navigable canals all around. A great fortress. You may have heard of this being so. It was there that Alexander the Great established his capital in 329 and there he died. This was one of the great empires. Ceramic water distribution pipes in Nippur, another of the Babylonian cities. This one is not very old, it is only from the 2nd millennium BC, we have already passed from the 4th, to the 3rd and now to the 2nd millennium BC. We are going to make a somersault because we are going to 1520 of our era, to Lake Texcoco, where the ancient Tenochtitlan was, which is today's Mexico City. Why? Because it is a culture that was in the Chalcolithic period, exactly like the ones that were here in the 4th millennium, in Europe and Asia. It is very ancient, but we know a lot about it, thanks to the arrival of the Spaniards, and everything they had and their things and how they lived their lives is perfectly described. This is a map of what Mexico was, an impressive city, with a strange cultural level, but important, because they had their water supply. In fact, the Spanish discoverers themselves speak in that sense, that they did not know of a bigger city anywhere and that it was bigger than Venice, the Venice of that time. It had a water supply that carried the pipes of Chapultepec, which are powerful fountains that come from outside the lake. Despite the technological level and even in agriculture they had made certain developments, they also had irrigation of all kinds. It was a strange culture, because socially it was terrible. They ate each other, a disaster. One of the taxes they charged to their enemies, because it was an empire that sowed terror, was on people, to sacrifice to the gods. It was a genocide what they were committing there, which Cortés stopped. Now that the American genocide is so famous. The only one there was is the one Cortés stopped, which was very big, 20,000, 30,000 a year. They were killing each other. Not only the Mexica, the Tlaxcalteca, which was the enemy tribe, did the same thing when they took prisoners from these people. But they had water supply, in the Chalcolithic, in the Copper Age, because they were in that cultural moment, hence also a little bit the ease of the conquest. We were in the Renaissance and we carried gunpowder and we also made aqueducts and roads and everything when we got there and when it was conquered. Let's go to a very ancient realization. In 2300 BC, we are talking about the third millennium. A pharaoh named Amenemhat III irrigated a dry endorheic basin, which was not reached by water, which is lower than sea level, as there are other areas in the east, such as the Dead Sea, which is naturally flooded, called El Fayum, which you may have heard of. The region of El Fayum is one of the richest regions archaeologically and of course agriculturally in Egypt. We are talking about 300,000 hectares that became irrigated. This almost doubled the agricultural extension in 2300 BC by a pharaoh. He diverted a canal from the Nile, as you can imagine, on the left bank, flooded the basin and irrigated everything that you are seeing in this satellite photo, even the surplus, the scouring, which is now called, formed that lake that you see there, which is the lake of El Fayum. There was even a city that flourished there, whose remains are continually being excavated and which was called Cocodrilopolis. This went from being a desert to a crocodile nest. Amazing. This is the scheme that you are seeing of irrigation, of what then logically has been perfected over the centuries, because the canals, if they are not maintained, they break down, they close and become terrified. It is not a mistake, it was like that, 600 meters wide. They are also perfectly navigable canals. The slope is 0.01%, 10 centimeters per kilometer average slope, 300 meters, 500 meters, that is, it is a brutal excavation. The flows were tremendous. This also served to regulate the flooding of the Nile. When there was a big flood, they used the canal itself as a regulator of the excess flow. You will have heard very strange things. I have heard them even in Egypt and the guides tell it to the tourists, a disaster. They say that when the Nile overflowed and irrigated the fields and then returned to its bed. And, obviously, that is of no use, you have destroyed all the irrigation ditches and all the irrigation. No, that's not how the Nile floods worked. They filled perimeter canals, which still exist, they are maintained and some have been abandoned. They filled this canal and with them came the whole season. That was the way in which, when the river rose, they regulated with the canals and then irrigated the irrigable area, but they did not let the river flow out and flood everything because that would destroy the field for 20 years. But, friends, that is what is interpreted and what is written in the books and what is studied in the universities. Because these things are like that, because there are surely no agronomists who say, where are we going with this? This cannot be like this. This is a map of El Fayum today, which I have deviated a little. You see a detail map of how it had several processes of restoration of new channels. And this is what it was more or less in 250 BC, as you see here. Then, in addition, in the Hellenistic world and in the Roman world, this is characterized by some burials with some portraits. This is a view of the lake. These burials with absolutely realistic portraits, which portray the dead perfectly, there are many, there are hundreds in museums. These are the famous portraits of El Fayum. The civilization there has been developing through the centuries, until today, thanks to the derivation of a canal started by a pharaoh in 2300 BC. Be careful with the topography of this guy and the magnitudes of these works that I am telling you about. The Minoan civilization, 20th century BC, Knossos, the city of which Knossos. Palatial cities that were practically city-states, but belonged to the same civilization. Knossos is the best known, in Crete, the current island of Crete. Here you see the ruins, what remains of it, some aspects. And suddenly in the subsoil you find this, ceramic pipes that carried water. They had water supply, they had latrines, they had sewage, they had everything. In the museums there are this type of tongue and groove ceramic pipes with which they carried the water. barely subjected to pressure, because it was really a closed channel. So, they let it circulate by gravity. It seems that the water did not come from very far away. In 3, 4 or 5 kilometers there are fountains, but they had it. 20th century BC. This civilization was for the Romans as old as for us Romans. It is very important that I tell you from time to time this time scale, because one gets lost in these centuries. Here you have these archaeological drawings from many years ago where they explain that this existed. Latrines, there were some wooden benches with a hole, just like the Romans, opposed, each one stood on one side. And those are the latrines. Normally they didn't stand collectively, they waited for each other to go out before the other one came in. There is a lot of invention on this matter. There were several latrines, one might be dirty, so you choose another one. That's the thing. But there were latrines, drainage channels, sewers, there you see them covered with slabs. Here you see one of the main ones, in one of the streets. When I went to Knossos, I photographed this. People photograph other things and I only photographed this, which was what interested me. Here one of the main ones in one of the streets that is still with the slabs, almost all modern because they were broken, but this is one of the sewers of Knossos. 20th century BC, Triata is another of the cities of the Minoan civilization that is in another part of the island, also had water, of course, had everything, has its channels that here you see how they have tried to rebuild. They are rainwater, sewage, all kinds. Actually, this has been excavated mainly during the 20th century, from the beginning of the 20th century until the 50s or 60s when the excavations were interrupted. I am afraid that in addition to the pipes that have been found, they have not carried out major studies, in the sense of knowing where the water comes from, what is the sewage system, what is the sewage system, where does it end up, because this is not of archaeological interest normally, nor do they have a domain to be able to study it much further than to treat what they find and little more. Let's go to another great achievement of antiquity that today would surprise anyone because it is of enormous magnitude. We are going to the Mycenaean civilization, in the region of Crates, 1450 BC we are talking about. This is Lake Copais, it is a lake that had 40,000 hectares, about 40,000 hectares, and it was drained by the Minoans in 1450 BC. Here you see one of the perimeter canals, which you can see here, which is one of the main channels and what was the lake. In this area, around here, there is a Minoan city, a fortress that still exists, and it is being studied archaeologically called Gla, which is this one that you see here, near the modern cities that you are looking at. This is one of the watercourses that they managed to take out. How did they do it? This is the city of Gla, a view with all its wall, huge, with cyclopean stones. You know that Mycenae, which is one of the capitals, has a wall with irregular polygonal cyclopean stones, perfectly adjusted. They worked almost as in Cusco or as in other civilizations that later have worked that type of well-adjusted cyclopean stone. Here is another view of Gla. And this was the drainage system they invented, 2 perimeter canals that raised the water enough to be able to go outside as you can see, and the deepest part, which could not drain with these perimeter canals, they made a tunnel that communicated with this other lake that is further down. This is the longitudinal profile of the tunnel and the manholes that were made. Mycenae, 1450 BC, 40,000 hectares of arable land that were found perfectly flat and irrigable after the drying up. This is one of the manholes. These are photos that I have been catching around so that you can see it with a little more detail. Another of the Pharaonic works, never better said. The Canal of the Pharaohs. The Canal of the Pharaohs was begun in 1250 by Ramses II, one of the great pharaohs. He intentionally interrupted it because the Persians were at the gates of Egypt and they told him that if he completed the canal they would enter through there, and they were absolutely right because in the end they entered through another place, but they entered, to the point that Darius I completed it in 550 BC. Once he conquered Egypt. The Canal of the Pharaohs is this, the first Suez Canal, a canal that communicated Memphis through the Tenitic branch of the Nile with the Red Sea, with Suez exactly, down there, passing through the Great Lakes that later occupied the Suez Canal that you have here, in this aerial photo. It was really made in the 19th century, but of course this already occurred to the pharaohs who wanted to communicate with the Red Sea, because there was a lot of trade in the area of Arabia and in the Indus area. Here you see a detail, in this case from Bubastis because Memphis and the current Cairo, which did not exist, Memphis goes by the Tenitic branch to here and then already communicated with the Red Sea. This is another aerial satellite view of what is now the Suez Canal and the lakes. You see how here there is still a trace of what was the Canal of the Pharaohs that was gradually closed. In fact, Trajan reopened it in Roman times, opened it and put it into operation, and at the end of the empire it was closed again and no one has ever put it into operation again. They decided to build the Suez Canal because the objective was to communicate the Mediterranean without going through the Nile, logically. This is a view of the modern Suez Canal, of its profiles, both longitudinal and in this case of the plant, etc., so that you see a little the dimensions of the Suez Canal in the project of the 19th century already. We have had to wait 19 centuries plus 13 to have to return to communicate the Mediterranean with the Red Sea. They had made a channel that already communicated the two seas and we without knowing it. Let's say it this way, some know something, but it is very unknown this. This is the size of today's Suez Canal. Of course, it's an aircraft carrier, it has tremendous dimensions. Let's go to another type of great engineering works of antiquity. 627 BC, Periander decided to connect the Strait of Corinth, where later the Corinth Canal was built, which you know exists and is another of the shortcuts that the Aegean Sea has for ships, which is this one here. But there are other great canals that were made at that time. Another one cutting the peninsula of Mount Athos, here in the Chalcidia, and another one here. And finally, here, also from the same period, for war purposes, a 2 kilometers long bridge of boats on the Hellespont, to cross the troops of the Persians in the conquest of Greece, Athens, and Sparta, in the Second Medical War. I'll tell you about it later. This is the present Corinth Canal, and here, in this area, this road was developed, by Periander of Corinth, which is the Diolkos. It was called this way. A road with a good layout by which, with wagons with wooden axles and wheels, they transported the ships from one side of the strait to the other before making the canal. And that you see here half excavated is the attempt to build the canal by Nero, already in our era, but Nero wanted to make the Corinth Canal the first of all. He was killed before this and could not finish it, but he had his intention to do it. Until the 19th century it is not done. These are the archaeological remains that have been left of the Diolkos, with the rocky rock carts that transported the boats. Ancient sources mention that this existed and the road has been found. Here you see other remains of the Diolkos in Greece. Very few people visit this, other things are visited in Greece, but these great works of antiquity are not among the most visited. Here you see other aspects, and so on. You can see how they were excavated in the 1960s and how the sea itself has destroyed it, because it has been left quite abandoned. This logically had a certain firmness on top, those are foundation stones. What happens is that these things are excavated until they find the fat stone, which is what they like, but there were gravels there to be able to roll in conditions. Here you have another unfortunate example of how it was in the year 60 and in 2006 this excavation had already been practically destroyed. Here you can see 19th century plans of how, before building the present Corinth Canal, there were already some wall ruins. The Diolkos was not yet well identified, but the remains of Nero's canal, with the trenches that Nero had begun to excavate, which were practically used to build the present Corinth Canal. This is the current Corinth Canal while it was being made in the 19th century, a tremendous work, brutal for the means that were then available, of course, pickaxe and shovel, don't give it any more thought, zero machinery. All kinds of people were employed, I believe that, in some photos, one of these people looks like a prisoner. You see the vertical excavations, still today you can see this canal those of you who go there, to communicate from one bank to the other, a road. This is a current photo of the Corinth Canal that was made in the 19th century. But since the most remote antiquity at least Nero already wanted to make what was a canal, to abandon the road that was not practical for him and make the canal. These are photos of the Corinth Canal. Well, this is Athens in 540 BC. One of the best rulers that Athens had, who was not a democrat, so there were two regimes that alternated, democracy and tyranny. Tyranny was not like the concept we have today because of a tyrant, but democracy failed from time to time and they put in a tyrant. This is a man who beautified and aggrandized Athens in a tremendous way. Pisistratus. Among other things, he built several aqueducts, one of them tremendous, which brought water to the city of Athens, because it was a city of an impressive size, as you can see. There you have the Acropolis and the Parthenon and all this. Indeed, there are many remains and every time they make a work, the subway or whatever, in Athens, the pipes appear, which as you can see did not work under pressure, but they were a kind of subway channel, which are also all registrable so that, if there was a clog, as they were more or less accessible, a man would go down and put his hand in and remove the clog. You see here the remains of the pipes in the museums and outside the museums, in the streets when there are works, and a man reaching down, as I said, to see what is inside. This has been unusable for many centuries. At the end of the Roman Empire it disappeared like everywhere else. Great subway achievements with which people are still surprised. The Eupalinos Canal, in Samos, on the island of Samos. You see how they are water supplies where the springs were on one side of the mountain on the island of Samos and the city was on the other. My goodness, instead of making the city on the side of the springs, they made it just the opposite. Well, they drilled the mountain and took the water, with a layout and plan that you see here and with a layout and elevation of the gallery, that you see so straight, because in the canals as you know the only thing that matters is the longitudinal profile, the plant can do whatever it wants, because the water will go with the slope that it has. This has given rise to many hypotheses in archaeology. They were wrong, they did not know how to do subway topography and they had to do it many times until they found it. Well, that is not true. It is not true because I have had the opportunity to investigate it and to visit many subway galleries, almost all of them Roman, with geologists, who are the ones who know about this, and they told me, look, they follow this dioclase and go through the softest part, they turn this way to take the softest part, they break their horns here because it is massive rock, and they knew what they were doing, and then they went back to where they wanted to go. They handled the subway topography just like the outside, without any problems. This is a very singular canal, very famous, because this is also a visiting gallery and the canal goes down there. Curious, because they also put a pipe in this canal. In the end it is a pipe under this excavation and this is a gallery through which you could visit the whole canal. This is the scheme, that is, this is a visiting gallery. Forget about the meeting points that they put here, they made them as they pleased. The important thing is that they could visit it, and this is what had to have a correct leveling, where they then put the clay pipe so that the water would go by gravity and by its weight, with the appropriate slope, from one side of the mountain to the other. And it worked for many centuries. Here you see the visiting gallery and under those grids that have been put so that people do not fall, with some intermediate reinforcements that are there, so that the rock does not expire and does not close in the excavation, because there under those grids is where the pipe would go and where there are still remnants of pipe. This is the famous Eupalinos Canal on the island of Samos, very famous in the world of archaeology, perhaps unknown in the world of engineering, but one of the great works. We are talking about 540, Eupalinos of Megara was the one who made it at the time of Polycrates, 540 BC. This is one of the access points to the canal. It is not, it is the canal itself. And, indeed, there were difficulties in some of these subway channels, of which many were made throughout the Mediterranean. This one, for example, of Saldae, which is already from the 2nd century after Christ, where they had to call a wise subway topographer called Nonius. Nonius was when they had a problem of topography. They had been excavating for a long time and they realized that they were not finding it. They were making mistakes and it was this gentleman who must have known very well, and he said this is this way and they found it. That is why they erected this commemorative stone with his text in which it says that, thanks to this man the canal could be finished with his wonderful help. We continue, in the 6th century BC. This is a general view of Persepolis, the capital of the Persians under Darius I, founded by Darius I, a city founded on terracing that had its supply and its sewerage. In fact, it was the first thing that was done, the sewerage. They landed the city, they brought the supply by a system of called quanates, which are subway channels, and it was supplied. These are general views of Persepolis with its terracing and its points of habitation. This is Persepolis in a photo of the last century, and you can see how these little holes you see here are manholes of subway channels, not of Persepolis, but they have taken advantage of the water that was coming through there and was being lost to take it a little further and irrigate other areas, because the channel of Persepolis, as Persepolis was not inhabited, they have taken it somewhere else. There are quanates all over the desert, with their manholes that have to be refreshed from time to time, because the desert covers them and seismic movements can ruin a lot of channel and you have to rebuild it again. But well, for centuries they continue to function. Here you see them as they are all over the areas of the current Persepolis, which is in Iran, but this has its origin in the 6th century BC. The Romans invented very little in this matter, practically nothing, almost nothing. What they did was to spread it all over the Mediterranean, which is not little. It was the big bang of engineering, but the inventions were already there and the techniques were there, etc. Here you can see details of the quanates of today's Iran. Later, this has been done in Spain, in the Roman world as well. There are a lot of aqueducts. For example, in Merida, there is one that is a kind of qanat, but the manholes are made in the factory, they are no longer in the ground. This is the scheme of what a qanat would be, how the subvalvous mantles of the zones in the mountains are captured, sometimes far away. I believe that in Persepolis the length of the main qanat is 60 kilometers. They capture the water with their manholes, the subway channel works until it reaches its destination. In this case you can see that the water comes out, because it will be for irrigation or whatever, but this reached the city and there the water was decanted. They had large decanters, just as it was done in the Roman world. This is a current qanat working with water, so you can see what it looks like inside. Here you can see what a subway gallery is like. There are many of these, also in Spain, I insist, in the Roman world, in pieces or whole, channels that have been made with this subway technique, whatever is needed according to the orography. These are clay pipes from Persepolis itself, that is, when that came the city also had its distribution, with clay, etc. Sewage, also from Persepolis. These are photos of Persepolis. Let's see other great canals and great achievements that I have told you, also from the ancient world. in this case also from the Persian world, from 472 BC, which is when the Second Medical War was fought by the son of Darius I, Xerxes. Darius had failed here because when he reached the peninsula of Mount Athos there was a gale, a storm, which wrecked his fleet and he had to turn back. A disaster. In fact, by land he arrived a little further. It is the famous Battle of Marathon and it did not go very well either. So, Darius did not manage to conquer Greece, or anything, but his son Xerxes did. The sources say that Phoenician technicians were the ones who cut the channel of Mount Athos to pass with the fleet of 700-odd triremes, a very powerful fleet, and I think about 200,000 men, by the bridge of boats that were made here in Abydos, as I said before, by land. They went in parallel. This is the famous Battle of Thermopylae, the Battle of the 300 of which they have made a movie like this, very tacky, of bodybuilders with shields and swords. Indeed, they were beaten by the Persians, Sparta, Athens, and Thebes, the three cities of the Confederation that existed. They beat them up and defeated them on all sides. In this war, evidently, the bad guys were the Persians. In fact, in a way, Xerxes is considered arrogant, because the first storm when he was building the bridge of boats broke it and he took a stick and hit the sea there, in the Hellespont, because he had broken the bridge of boats and he had to rebuild it and finally they passed. But of course, the documentary source of all this is Herodotus, a historian of 440 BC who lived around here by the Turkish Ionia, who was Greek. Then, evidently, the bad guys are the Persians in this war and, however, the Second Medical War was won by them. History is like that, the one who writes it is the one who puts the bad guys and the good guys. And, indeed, this channel that you see here allowed him to make this route instead of being shipwrecked, as happened to Darius, when he went around here, because this kind of cape, this peninsula, is very bad and when the wind picks up, the ships have a hard time. So, he made this channel and since then it has been made in a city called Uranopolis nearby. Here you see plans from the 19th century where you can see the canal, when they identified and mapped the remains that are left of it, more or less it comes from here to here. Today it's closed, but there it is, the canal, the extra trenches and all that. You can see it perfectly and there's the Xerxes Canal. This is an aerial view of another canal, in this case in the Pythagorean Canal, which is the peninsula that is more to the left. This one was made by another character, in 315 BC, that is to say a little later, whose name was Cassandra. In this case we are talking about one of the kings that Alexander left in the area, in the Hellenism, which is called. This channel is still in use, it is short. It was of no use to Xerxes, but Cassandra thought it was good and today it is working, so that it can be seen from the airplanes and from the ground and it is a canal that is working perfectly, the canal of the Pythagorean Peninsula that Cassandra ordered to be built. Here you see another desiccation of a huge lake, Lake Bizergan, which has a tunnel. The lake is all this that you see here. This I have personally visited, it is in Turkey in ancient Turkish Lycia. By means of a tunnel they drained it to the outside, they broke the endorism. I do not remember the hectares, but they are of the order of 15 or 20,000 hectares. We are talking about a huge interior lake that you see here. The tunnel has a constant maintenance. In fact, it has had maintenance in the present centuries, because if it does not puddle quickly, if it is not maintained, it gets terrified and has problems. This is the trench approaching the tunnel, the old trench, the entrance to the tunnel, the interior of the tunnel, and so on. Let's go somewhere else, to Ephesus. Ephesus is a city of Hellenistic origin, later Roman, huge, one of the great Roman cities. In 300 BC it was endowed with a port which is the one you see there in the background, impressive, which is this one you see here, which communicates with a long channel, quite long, with the sea. They are inland ports, more or less at a certain distance from the sea. As you can see, here is the sea, here are the remains of the port and the channel was this. Logically it is all closed. This is a reed bed and when someone visits Ephesus and the theater and all those things, you see a reed bed down there that unfortunately nobody explains and it can be one of the most interesting things that Ephesus has, its port and its ancient communication channel with the sea. This is one of the aqueducts of Ephesus, water supply pipes of Ephesus, made of clay as you can see, a tremendous network, everywhere you can find pipes, one of the most interesting things in Ephesus, of all sizes, for the different endowments, the baths, the fountains, the individuals, those who turned off the cannon, and so on. Frontino explains very well these things for Rome that is perfectly extrapolable to the whole empire. There were also stone pipes, supply pipes, as you see these in Ankara, today's Ankara ancient Ankara, huge cities that flourished, thanks to water, of course, as I told you from minute one, like this one in Patara, which had its Odeon, its theater. Also of Greek origin, all these are of Greek origin. Then, also in the Roman world they flourished, but they are of Greek origin. Here you see an aspect of Patara, and this is the siphon of the Patara aqueduct, a siphon that went by gravity, by a covered channel and continues here. But this small watercourse, as it does not have too much pressure, they solved it with tongue and groove stone pipes with a little bit of lime grouted. And it worked perfectly, of course, it worked perfectly in the life of the city. There are a lot of these things in the East. In fact, the aqueduct of Cadiz is of this type. The aqueduct of Cadiz has a great length of this type of siphon, with not much pressure, but a siphon of tongue and groove stone pipe. Decanters, always in the highest zone. Always, in the cities these deposits are in the highest area. When you see a Roman archaeological site, or whatever, you will read some absolutely strange interpretations that speak of cisterns and these imprecise names, that speak of water stores, of regulators, what we understand by regulators, but this did not regulate, these are decanters, the water entered from above and came out from above. The water was there for several days purifying the solids, that is a decanter. And that's how the water supply worked in the Roman world, something that is largely unknown, so that even, as the people who study these sites do not understand how they could bring the water up there are many techniques. They end up saying that they drank from the rain, that it was filled with rain. You will see it in many sites. Of course, how do you get to a reservoir that sometimes are like industrial buildings, on the highest point of a hill? That's absurd. And with rainfall of sometimes 300 millimeters. I have seen that they put it there, they put it on the signs. They were external contributions, by siphons or by other types of pipes, which have not been understood or understood. Here everything remains to be done, everything to be done that should be done by engineers, who are the ones who understand these things and could solve it, and they will never do it, because they no longer study it. The subject of history of construction no longer exists, so we will continue swimming in the most absolute obscurantism in these things for many decades. Here is another view of Patara and of a lighthouse in the harbor as well. A preserved lighthouse from Nero's time, impressive. Cities that prospered in an impressive way, thanks to incredible aqueducts. This is Aspendos, and this is one of the load-breaking towers of the Aspendos aqueduct. An aqueduct that had 3 alignments that bridged this whole valley, with stone piping above the aqueduct, and that, to avoid the pressures that occur in the bends, because it had 3 alignments in plan, they made these small towers, brought the water up, to a tank, broke the load and made another siphon, but in a straight line, so that they avoided the elbows in the angle, and it worked for hundreds of years. They have Byzantine repairs, even, this aqueduct. Today is a ruin everything, the city, the aqueduct and everything. Aspendos in Turkey. Palmyra, in the middle of the desert. Palmyra flourished in a tremendous way in the middle of the desert, with a very powerful aqueduct. These cities cannot be inhabited in the middle of the desert bringing water jugs with camels. This does not make any sense. Look at what Palmyra was. And these are the stone pipes that brought water to the city, kilometers? As many as it took. They had their aqueduct, of course. These were the cities of the Decapolis, which was called that way, in Syria. The Pentapolis was another series of cities. This is Gerasa, look at that elliptical colonnaded forum, impressive. This is one of the most impressive ruins in the empire. They had aqueducts sometimes incredible in length. This one of Gerasa, that I have told you, had this monumental fountain at the arrival of the aqueduct. They are called nymphaeum in archaeology. In this nymphaeum the water gushed out. There are many, all the cities in the area of Turkey, in Lycia, all have this kind of nymphaeum at the arrival. The water flowed with monumental spouts, statues. Sometimes the water was wasted through ornamental channels along the avenue that went directly to the sewage system, because both in the ancient world and in the Roman world, a large percentage of the water that reached the city went directly to the sewage system, which kept the sewage system clean of excrement and all kinds of impurities. That is true sanitary engineering, because they had no greater possibilities of purification. This stopped happening in the Byzantine world. In the Byzantine world aqueducts fail in the east, well, everything fails here, but in the east, where the Eastern Empire continues a little bit, aqueducts fail. They begin to store water, and there they are already regulators, like the famous cistern of Justinian, in the Yerebatin cistern, which someone will have seen in Istanbul and many others, because there are 10 in Istanbul, no less, and they store water. Of course, the aqueduct brings little water, it does not always bring it, they have to store it, they drink stored water, it is no longer drinkable, it is no longer running, and above all they do not clean the sewage system. Well, the first huge epidemic in the history of mankind, bubonic plague, arose there. You feed the rats and the rats will feed the other. But this was not the case in the ancient world. In the Roman world that did not happen. This is another of the huge cities in the desert of Algeria, Timgad is called today, the ancient Thamugadi. Look at the dimensions of these cities in the desert. Of course they were supplied, as they had fountains in every corner and even ornamental canals along the avenues. They brought water from wherever it was needed in enormous, unbelievable lengths. This is Gadara, another of the cities of Jordan, also of the Decapolis and of these cities. This city has the peculiarity that it has 170 kilometers of canal to bring water to it, from these springs that are here, near what today is this reservoir. Of the 170 kilometers, 100 kilometers are tunnels, subway galleries, uninterrupted, 100 kilometers of uninterrupted gallery. It supplied several cities. You can see that in the middle there are several cities that were also Roman, several Roman cities, but look at the works, the aqueducts, because it was an urban civilization, it was a civilization of the cities, and without water there is no city of any kind. So, this type of engineering works was essential for them, and they made them. It was a very powerful state, with a lot of money. They collected taxes all over the Mediterranean. This was done by specialists. Everyone, from the one who planned to the one who projected and even the one who excavated, was paid for it. This is well known from the Vipaska tables. Even the miners were people who were paid very well. The issue of slaves was circumscribed to other areas. But I cannot now diversify in this matter. The talk is about something else. Decanters, already of Greek origin, also in Spain, in Ampurias, the Greek city of Ampurias. The Greek part has this type of decanters. It has several, it has many. The same, it does not have any entrance or exit at the bottom, because they are of singers. It enters at the top and exits at the top, and as they have many, they emptied one of sand or impurities, while the other one was working. This is how it worked in all cities. There are many of these in the ancient world. This one curiously is from Illustrit, an Iberian city near Ampurias, and is clearly a Greek decanter made there. Of course, they are contemporaries. They traded with the Greeks, and among other favors they did them was to bring them water and put them a decanter. Iberians who would certainly be in precarious and said, the only thing we lack is water. Well, the Greeks put it, and that's how the city of Illustrit has several decanters. Here you have this strange thing that is above Ampurias that they say is a sand filter. I don't see it. It is probably an ornamental fountain, that is to say, as it is in the high area, the first water came out of there. It is a kind of small nymphaeum, because I have seen several of this type, several artifices of this type of fountains, precisely in Perge that I mentioned before, and in Lycia, there are several of these clay pipes that are ornamental fountains, at the end. Decanters that are real industrial warehouses in series, enormous. This is Carthage, the Roman Carthage. This received from the aqueduct of Saguan, in which the sources of the city of Carthage are 150 kilometers away. It receives immense flows, decanting that needed these immense decanters, which in the literature are not interpreted as decanters. If you have 3 cubic meters per second in the city, what the hell are you going to store for? Because that is permanent, and also, they had several aqueducts, not just one. What they needed was to decant, because, although the water comes out pure from the sources, after 150 kilometers, it arrives full of sand, it wears out the channel itself without going any further. These decanters, which are impressive, one of the largest in the empire, are those of Carthage, but there are many, in Spain itself, Roman, larger or smaller, misinterpreted, but they are everywhere. Distribution pipes, hot water because they are hot springs. Well, this is Bath in England. I put the photo because there are both things. One of the lead distribution pipes sealed with a cord, etc. Latrines, as I have told you, of course, these people had latrines and running water, and, indeed, the water circulated down there. It carried away the excrement immediately, which is very interesting, because until we flush the toilet it is a mess. And then, in addition, they washed themselves with water that circulated constantly through this little channel. That is to say, do not believe these interpretations that they had a toilet brush and wiped their asses. That is nonsense. The brush was there to clean the latrine. Besides, the sources come to say even that, but it is misinterpreted. I have a paper about this published and even a video on my YouTube channel in which I explain the nonsense about the interpretation of the xylospongium, which is a stick with a sponge, that is the xylospongium. Sewers. All Roman cities had sewers, of course. This is the one in Cologne, for example. And finally, this is still happening in the 21st century in large parts of the world. If the water does not go to the city, people have to go to the water, which is sometimes many kilometers away. To give you an idea of the importance that engineering, civil in this case, has had throughout history, from the most remote antiquity, because we have been talking about the use of water, water management, even large drains, and that it still continues to have in these places that are not endowed with it. And that's all for today. Thank you for your attention.